go ahead and bail into this. Everybody get your fanny, sit down in your seat. We're going to talk a little bit. We're going to expose you to the 7.3 Power Stroke Fuel System. This is part of a class that I taught in Fort Worth, Texas, and I also taught it in El Paso, and I taught it in Houston. And so you guys are getting for the benefit of just being enrolled in my program what some other guys paid some bucks to do. And I had pretty doggone good attendance in these classes too. And the class I taught out there whenever I went from start to finish was 480 PowerPoint slides and lasted 8 hours. This one here is not going to be that long.
They have external oil pumps, don't they?
Yeah. Well, we'll talk about that. That's actually going to be in tomorrow's session. Today, we're going to cover the fuel system. All right. This right here is your direct and your indirect injection on your. This is the old 7.3 versus the new 7.3. All right. What you hunting for? You probably won't find one in here because everybody always pirates and see what you can come up with. But anyway, you get your indirect injection, sprays the fuel into a little chamber here, right there where the glow plug is when the glow plug's working, and then that goes in here and it lights off and all that. Now, how close? Remember I asked you this the other day on a diesel engine. How close does the piston come to the head whenever it hits top dead center?
Like
40.
I'm good to go, right?
Yes, sir. Okay. Good to go. It's a good place to eat. You have some dinner with it.
Thank you.
All right. Hey, I got the solenoid coming. What we need to do at some point is put that solenoid on there so that you can isolate those two batteries, because it came without one and they're just parallel.
That's the problem.
Yeah, that's a problem.
Yeah.
But
Okay.
anyway, it should be okay.
You let me know when we'll schedule that.
Yeah, right now it's like it was before before the alternator went bad. So go for it.
I'm gonna bring you gonna look? Y'all be able to look at my truck in the morning?
Yeah.
That little engine on there?
We look at you.
Okay.
If I got some people that ain't sorry dogs.
Okay.
Okay. All right then. We got some this direct injection right here. Basically, what you got, see, is you got, what's this right here? What's usually green?
fuel.
That's coolant right there. And it's around a little cup that the injector sits in. But you notice this is spraying directly in, and the combustion chamber is in the top of the piston, more or less. The sides of the piston actually come up pretty strong there. All right, diesel fuel systems can be divided into two subsystems: the fuel supply system that draws fuel from the tank and delivers it to the fuel delivery system, and the fuel delivery system delivers fuel into the combustion chamber. On the older Power Strokes, not just Power Strokes, but on the older diesels, the injector pump worked sort of like a distributor, and it had these stiff steel lines that snaked over there to the injectors, and each line has to be exactly the same length. If somebody builds a line that's not exactly the same length as the other ones, it will misfire on that cylinder. I have seen that. Also, it cannot have a bend radius more than about 2 inches, if I remember right. Also, you might notice on those rails how they're clamped down really tight with these little rubber things so that they can't move a lot. And that's the timing of that injector spray as it goes in there and pops the little pedal off that injector is really critical. Well, there are two types of fuel systems used on 7.3 DIT diesel, and then the return and returnless. The return fuel system, 98 and earlier model, this will be your suction. That's low pressure, that's high pressure, that's return fuel. This big filter cartridge, there's one of those laying behind you on that table over there, by the way, that we had to change out for somebody. This right here was a lift pump. This rides on the camshaft, and this basically pulls the fuel out of the fuel tank through this filter. And there's some return right here, there's a little spring and a plunger in there, I'll show you in a minute. And it feeds it into the fuel rail on the heads, where the injectors actually are actuated by high pressure oil to drive that piston down and pop the injector. Okay, you got a 2000 F650 and F750, that's a returnless fuel system with a mechanical fuel pump. And there's your mechanical fuel pump, and it's slightly different piping, don't worry about that, it's got this little funky thing here. All right, returnless system with electric fuel pump, mid-model year. Now there's a question that's going to seem like a trick question in here. There is a slight amount of return on this returnless system. It does return some fuel. You know what I mean? So you might even notice when they call it returnless, it still has a return line that goes down here. All right, here's your fuel tank pickup. You might notice the way that thing's set up right there. Fuel tank intake constantly draws from the very bottom of the tank to prevent the buildup of contaminants as water and microbiological organisms. Diesel fuel likes to grow algae. You know, it seems like nothing would grow in diesel fuel, but it will. I mean, you can actually get a whole lot of microbiological junk growing in there that'll clog stuff up. All right, the contaminants are removed by the fuel filter assembly. Now this nib assembly sits right on the bottom of the tank. And there's another, and because it sits on, and I'll show you a little bit more about that in a minute, but the fuel pumps used to pull fuel off of about that far off the bottom of the tank. Like on that Bronco, we put that in there. It didn't go all the way to the bottom. It was close to the bottom, but it didn't go to the bottom. And that gives water plenty of room to slosh around under there without getting picked up. Well, somebody early on, well, I say early on, later on in the 90s decided, well, why don't we just go ahead and put that thing all the way against the bottom of the tank, and then as water goes in there from condensation, we can process it and it'll just go through there in little small amounts and it won't hurt anything. So you're going to find all of these fuel systems now drawing fuel right off the bottom of the tank instead of pulling it from the other. There's your fuel level sending unit. You got a fuel bypass valve. Now look at this. This is a cool thing I bet most of you guys didn't even know about. A diesel thermal recirculation module, DTRM. Most people, when they look into one of these, they don't even know that's what they're looking at. All right, there's your close-up of your pickup assembly right there. That's one that I took off and I had in my hand over here when I was working on these things. Within the part of the pickup unit called a thermal recirculation module, there's two little screens. You don't even know these screens are there unless somebody tells you they're there, and they can clog up. There's also this one down here. There's a screen on the nib assembly. That's that little nib assembly down here. And they basically, there's your thermal recirculation module. Talking about that. You see your little nibs? When those things are down there, it kind of creates a vortex, or I mean not a vortex, but a vacuuming effect, so that it will literally suck things in so they can be processed by these filters and everything. Globs of water or anything like that, particularly is what they're worried about, water. It's carried to the water separator where it's separated from the fuel. And there's those funky little nibs. You see those things right there. There's your little bypass valve. Okay. What I mean is that if that filter on the bottom gets completely stopped up, the bypass valve will still let it get fuel. All right, you got the screens located in the DTRM assembly used to stop smaller particles from reaching the pump. You got a spool valve in there. Return fuel comes out here. There's a little, there's a duct bill right here. Comes in here, goes out there. And then this comes in from the nib assembly. So the nib assembly goes down here. And there's those two screens I was talking about. All right. The thermostatically controlled spool valve in that DTRM, it helps maintain a normal fuel temperature 10 to 66 degrees Celsius, which is 50 to 150 Fahrenheit, in the fuel delivery system. What happens to diesel fuel when it gets too cold? It turns to jelly. It's going to do better if you can keep it kind of warm, right? So what they typically do is they let it, the engine warms it up as it's going up front, and then what comes back goes through that spool valve. The thermostat's exposed to the temperature of the fuel that has already passed through the screens. If it's cold, it contracts to let the warm return fuel to pass through the spool valve and go into the fuel inlet. In other words, it just totally recycles it if it's warm enough. If the thermostat's too warm, it expands and pushes the spool valve closed to force the fuel out the duct bill and into the tank. So if it's not always squirting fuel out the duct bill into the tank, the little duct bill is a little real. You might even have seen that. It's a little red thing that sprays that returning fuel out in a fan. And there's an important thing, and a lot of people don't even know about that. And we'll talk about that return fuel again in a minute. The mechanical lift pump has two separate pumps with one assembly. The pump is driven by a single lobe on the camshaft. You got fuel coming out. High pressure is sort of like an old-fashioned fuel pump pulling it in, but then it jacks it up to higher pressure, which would be 55 to 80 psi. Okay. All right. And you got an electric fuel pump on the 98.5 model year and later vehicles, except for the F650 and 750. It runs for 20 seconds when you turn on the key instead of the 2 seconds you get when you use a gas burner. All right, this right here is the water fuel separator assembly on the 98.5 and up model. That goes out to the return. Your water drain lever is right here. If you're going to change the fuel filter, you're going to screw this off the top. And you turn this little knob, and what's in here drains out. All right. Fuel supply from tank, you got water heater and fuel sensor right here. So if there's water in the fuel, this will turn on a little light on your dash, right? All right, here's your fuel water separator assembly on the older ones. This is not just like the one I showed you, this is the older model. That's pretty important stuff right here. There's a fuel heater right here. That fuel heater likes to short out. It's basically got power coming to it. It's actually coming from a thing similar to that. That's a water sensor right there. But it comes in the side, and it warms that fuel up in there. When it's got a little wire that goes around on some little composite pucks. It looks like somebody squirted some of that Gorilla Snot in there, and and it's insulated. Well, when those little pucks deteriorate sometimes, that little hot wire will get over there and touch this plate, which is actually, this is aluminum, that's plastic right there. And then there's your water drain lever on that one, and the water drain comes out here and it'll go into a pan and all that. If you ever leave this little, when you're looking down at the top of that filter, this little water drain thing is a yellow handle that sticks out and it swings from left to right, you know. If you forget and leave it open, it will actually, you'll leave a trail of diesel fuel going out of the shop and all the mechanics will laugh at you, right? Believe me, I know that from first-hand experience. Okay, this is left-hand thread. If you're having to change this fuel heater in one of those older Power Strokes, which was basically like the 94 up to the 98.5, their first generation, this is left-hand thread. So nobody, I mean, I'm telling you that because you don't want to screw this up and have to replace that whole $500 assembly right there if you can help it. All right, now this right here is your fuel pressure regulator. That's my hand holding it, by the way. Anybody knows my thumb and all would recognize that. I actually had one of these one time that came in that had low fuel pressure, and it was making it start hard. I think I told a little bit of that story. That was because that one had a bad pump. I also saw one that somebody had that out of there, and they had either bent the spring or screwed it up or cut it off shorter. I don't know what they did. And because that little spring was bent, the fuel pressure was low, and it was having trouble starting. A Power Stroke diesel, if the fuel pressure feeding the fuel rail is low, it'll actually start hard. And the oil control pressure is what we'll talk about tomorrow on the next part of this thing. You guys are going through lesson 1 now. I'm going in a hurry so we don't run out of time. There's your returnless type fuel pressure regulator that comes from right there. See, this is the older one. That right there, you screw that off and you put there's a special adapter that you got to put on there so you can check the fuel pressure with a conventional fuel pressure gauge. You can't just screw a regular Ford style fuel pressure gauge on that one unless it's set up to do the Power Strokes, because the spacing in that Schrader valve is a little different. All right, so the pressure regulators on both the return and returnless systems operate in a similar way. Each regulates the fuel at a different point in the system. On returnless systems, fuel pressure is regulated before it enters the cylinder head, and there's your returnless type regulator once again. On return system, it's regulated after it leaves the cylinder head. Also in these things, there are little bleeders. Like usually, how many of you guys ever run a diesel out of fuel and had to start it back up? What do you got to do? You got to crack all of those injector lines until it starts pushing fuel, and then you tighten them up one at a time. You don't have to bleed these. They've actually got built into here with that. Now they can actually bleed they're self-bleeding. So even if you've run it completely out of fuel and you're having to put fuel back in it, it'll usually fire right up because it's going to fill up, and there's little, you know the thermostats, how they got those little holes in them so that the air can leave the block? They're set up similar way to that. All right, fuel returning to the tank is sprayed out beneath the surface of the fuel. Listen to this. This is something that a lot of diesel mechanics don't even know. If that returning fuel, see that little fan thing right there, it sprays out the end of that. If it oxidizes and produces tar. And some of these Volkswagens and stuff, the little screen going out of the tank will get clogged up with what looks like tar, and that's because the fuel is going in and it's above the fuel level where it can actually oxidize, and it really makes a mess. So if you spit it out underneath the fuel so it never sees any oxygen, you don't have that tar forming in there, which is pretty important. So the fuel delivery system, the trick to get the fuel to cylinders is to use a pump to create high enough fuel pressure to overcome engine compression and inject the fuel at the right time. Remember, you've got 2 pounds of compression, you know, 2 degrees temperature Fahrenheit for 2 pounds of compression. It basically pushes that thing up, so when you spray that fuel in there, it's going to light off. That's all there is to it. And the older ones, they would send those high pressure pulses from that injector pump like a distributor, and they would pop those injectors that way. And the injector pop pressure usually runs from anywhere from 1,700 to like 3,800 pounds. Pop meaning how much pressure has to be delivered to the nozzle before it will raise the pendle against the spring and let fuel go in there. If you look at the tip of a diesel fuel injector, you cannot even see those holes. That's how little they are. They're teeny tiny little things. All right. So that's kind of a little crummy picture of what it looks like in a cutaway situation. There's the glow plug down there. I got a glow plug like that. The one I heated up the other day, I said, stick out your tongue. That's what this is right here. And there's your Huey injector. One of the problems we used to see was these O-rings would begin to deteriorate and come apart. And on the earlier Power Strokes, there was a little return line screen, and if I screwed that screen off of there, I looked and I saw little particles of O-rings. I had to pull all the injectors out and replace all the O-rings on them. I had to do that quite a few times. All right, this right here is the high pressure oil pump. And that goes in here and it basically feeds high pressure oil to this, and that solenoid got like 1 or 2 ohms. It operates on 115 volts. If you see the red tape on these wire harnesses, that means you're not supposed to go jabbing around in there with something, you know, feeling like it's a 12 volt system or something, because there's an injector driver module that juices that up to 115 volts and it'll fire you up. Well, you got high oil pressure, which is 500 to 3,700 pounds, and they're PCM controlled by high voltage signals. The high voltage signal opens up, and I'll show you how this works in a minute too, and lets the high pressure oil go in there and drive that piston down. The piston that actually operates the fuel is 7 times bigger on the top than it is the bottom, so that whenever, if you got 5 pounds of 500 pounds going in above that thing, which is the low end of this, 500 here, what is it going to be at the bottom if it's 7 times? 500 times 7 is what? Come on, guys. 3,500 pounds. Signal people are zoned out on me. Okay, so at the bottom down here, you got 3,500 pounds. Now I'm going to show you a cutaway of that injector and how it works. See that? There's your hydraulic electronic unit injector. And there's are all the parts of it right there. Your little electric solenoid up there. Why do we have an electric solenoid that's only got 2 ohms? Why would we have that on high performance cars? We got the high performance cars have got a lot less resistance on the injectors than a lower performance car, because the injectors need to operate a lot faster, right? So if you've got less ohms, you're going to have quicker action. High voltage, less ohms. You got a couple of ohms here, you got 115 volts. We're talking really, really, really fast, you know? All right. There's a spill spout right here. Now, if you look under the valve cover, you're going to be looking at this. And next to it, you're going to see a little hooded spout that comes out. And whenever it's running, when you got the valve cover off, you can see oil coming out of this spill spout. There's going to be a little spray coming out. If you see oil just hosing out of one of these things, then you know there's some kind of an issue. Incidentally, the scan tool test on one of these, if we can hook up to one of these days, I'll show it to you, has got what you call a buzz test. And what it does is it buzzes all the injectors. It goes, if one of them doesn't sound right, that's typically going to be the one that's skipping. You can count your way through them. It's doing them by numerical order, 1, 2, 3, 4, 5, 6, 7, 8. And you can find a bad injector. Listen to that. There's also a way you can connect a scope and find a bad injector. It'll smoke one of them out really fast. And I've got some scope patterns I'll show you, but it won't be on today's thing. All right. Here you got your plunger. You got your check valve. See that intensifier piston? All right, whenever this raises up and that oil pressure comes screaming in there, see this opens, this raises that up, oil pressure comes in there, which is fed from the oil rail right here, and then it drives that piston down, and then right down at the very bottom of it, you're going to have that little bit of fuel going in there, and the pressure goes here, and it's strong enough to jerk this little panel away from, and it's going to go, and it squirts, and it can actually control that with a pulse width. Electronic control solenoids, injector poppet valve, high voltage injectors, 115 volt DC, and 7 to 15 amps of current to operate. So that's a pretty strong juice there. Poppet valve controls oil flow in and out. That's what that deal is. All right, basically you got an intensifier piston there and a plunger, 7 times larger in surface area than the plunger. You know, this is 7 times bigger than that, what it amounts to. Then it multiplies it times 7. If you know anything about Pascal's law, that's how that works, right? Okay, nozzle assembly delivers and atomizes fuel in the combustion chamber. Nothing rocket science about that. You got your fill cycle, you got an injection cycle, you got end of injection. Pay attention, some of your test questions are going to be related to these, and I'm not giving you the answers. You make the grade you make, okay? I'm going through this. All right here, fill cycle. There's your high pressure oil right here. And then your atmospheric pressure is represented by this blue, and then your fuel supply pressure is down here. So oil's coming in from here. See, and there's actually an O-ring above that and an O-ring below it. You might notice that. All right, during the fill cycle, the components are returned to their spring-loaded positions. You notice all these springs in here. The poppet valve is blocking high pressure oil from entering the injector. Incidentally, these injectors were used on Caterpillar off-road equipment and stuff like that. And whenever you screw the top off of this big old fuel filter, you can see the fuel that they're using in there. When somebody would come in with one of these things running bad, if I screwed the top off of it and I saw red diesel fuel in there, which was off-road, I'd put it back on, put it outside, tell them go run at least 4 tanks of regular fuel through this, you know, not off-road fuel before you even bring it back. These right here are subject to have problems with gel and whatnot. If you run off-road diesel in there, which is untaxed, by the way, and it's cheaper. The most egregious offenders of that kind of thing are these ambulance companies that run for the county, because in the county, people can just sign away that, sign a waiver for those ambulances, and those ambulances used to give all kinds of trouble. Of course, a lot of these 7.3s are still out there, because people really love this old engine, as tough as an old boot, The plunger and intensifier have returned to the top of their bore at that point. All right, so the fuel fill check valve unseats and allows the plunger cavity to fill with fuel. And I'm going to show you this thing working in a minute. Fuel supply pressure here is supposed to be 30 to 80 psi going in there. And if it's low, you're going to have issues. The solenoid is energized, creating a strong magnetic pull on the armature. Overcomes the spring tension, and the poppet's raised to the top of the bore, which is that thing right here. Yeah, poppet, and that oil pressure comes in there, and it's pushing that down, right? And you notice it has basically lifted that, the pressure underneath here has raised that up, and it's letting that fuel, squirting that fuel out in little tiny holes. The upper poppet land close off the path to drain. The drain is going out here, so whenever it pops up there, you basically see that it can't get any drain. That pressure is trapped right in there. The lower land opens the poppet chamber to the high pressure oil. High pressure oil pushes past the poppet, so on and so forth. I've already gone over that. The pressurized fuel unseats the fuel delivery check valve. And there's a few little balls down here. The fuel delivery check valve there. And when the fuel pressure reaches valve opening pressure of about 2,700 psi, the pedal inside the injector lifts off its seat and injection begins. Now the newer fuel injections, this engines work different than this. We talked about that on another day. Injection pressures may be as high as 21,000 psi, depending on the requirements, and the amount of plunger travel determines fuel quality. Right? And then you de-energize the solenoid and everything collapses and it goes back like it was, right? Okay, poppet's forced down, spring pressure, upper land poppet opens, lets oil drain into the spill spout. You see all squirting out there if you're looking under the valve cover. Spring pressure and fuel pressure exerts an upward force on the plunger and intensifier, and flows upward around the poppet seat and out the fill. Now, these really were some good solid injectors, not to say you never had to replace any. One day I got to come in there and I had to replace his injectors to get one running right, and pull it out there to the right up here, and he goes, "So I'm not going to have any trouble." He goes, "No." I said, "No, you'll never even need another oil change, no matter what happens. Even if you keep the truck forever, it'll never be worked on again." He goes, "Oh, come on, man." I said, "Well, I don't know. All I know is it's running right now, and it wasn't when he came in here. He'll start with me." All right, so the fuel delivery check valve seats, and I don't want to go through. Now, I like to do this right here. Right here, I'm going to use my arrows. See it working? See?
Fast.
It's not fast enough.
20 milliseconds.
That's right.
Yep. Different top unit, refers to as a split-shot injector, has been used in 96 and later Californias, 97 and later, 7.3s, and then 99 and later. They went with a split shot over there, and the split shot injector could actually replace the older style injector because it worked a little better. It would initially squirt a little fuel to start the fire, and after the fire starts, it sprays the rest of it in there, smooths it out and everything, and it gives you some really good stuff here. A little bit of fuel just before it reaches top dead center. Just before it reaches top dead center. Did you hear what I said? The purpose is to help the fuel burn more completely, aiding in more dispersed power, lower emissions. Also helps reduce the knocking sound heard when initial combustion begins. In other words, it makes them run a little quieter. Interesting thing about a diesel, if it's a diesel with EGR on it, and these didn't have it, when you open the EGR valve, the diesel runs quiet. You expect it to run rough like a gas burner, but it quietens it down. All right, so the split shot injectors use a unique barrel and plunger. Look at this. It's a little bit different than just a plunger down there. It's got it goes past that hole, and that's basically what makes it, have that little split shot. See now, when the groove in the plunger aligns with the relief part of it, the injection temporarily stopped, and then it goes on down there. Fill stage, first injection, end of first injection, second injection. This is pretty slick. You got an open check valve. Check valve's closed there, and this is right down at the tip of the injector now. Is where you're looking at that. Right above the piston that's going to squirt the fuel. Check valve closes when the lower land of the plunger covers the relief port in the barrel, increases pressure, and it's unseated. See, this will take a little while to wrap your head around if you wanted to get that deep into it. Whoever's watching the video can pause it and look at the notes that I put on there. When the upper land seals the relief port in the barrel, the plunger continues to move down, delivering the fuel till the end of the injection. All right, let's see if we'll watch this right here. Injector control pressure versus pulse width. All right, that's my boot down there, and I'm holding the brake. Now, one of the things that you were supposed to do on these, whenever you're looking at the scan tool watching the control oil pressure, you're basically saying, I'm putting it in drive and letting it thunder. That's what you do. If you're gonna do that, it's best to go outside like Elvis and leave the building, because it is really loud when you're doing this. And if you can see that right there, your accelerator pedal is all the way down, your fuel pulse width, you know. It's hard to read those scan tool readings and all that. But basically what I was doing was I was trying to show you what the IPR is doing, what the, and we go into this a little bit later. I was just basically doing that myself so that we could get people in there. Okay, Slipshod injectors supply a small amount of fuel to the combustion chambers just after the piston reaches top dead center, okay? Let's keep going so we don't run out of time. Come on, buddy. Next question. I got to push the button. I think my battery's getting weak. Huh? All right. Is it? My PowerPoint's locked up.
Broke it.
Maybe. Maybe I did. Maybe I did. What are the two types of fuel systems for power stroke diesel engine? There is no fuel returned to the tank after it's been drawn through the fuel pump on a DIT returnless. True or false? Which component in the returnless fuel system with an electric fuel pump strains large particles from the fuel before it reaches the fuel pump? Huh?
Flux capacitor.
If you can spell those words, put them down, and I'll be glad to mark it wrong. Okay. All right. What are the three functions of the fuel filter assembly?
Separate water from fuel.
That's one.
Filter it and send it.
Write them down. What happens during the fill stage of the Huey Slipshod injector?
The springs, I mean, they return to the spring-loaded position. Return to the spring-loaded.
The fill stage. What's being filled?
The little thing down there with the thick walls.
So basically, what do you have? What's inside the injector? What What do you have in there?
Oil pressure and fuel.
Oil and fuel, and also you got atmospheric pressure, don't you? All right. All right. Lesson 2, the oil system. This will only take us another 4.5 hours. All right. We're going to start on that tomorrow.
Oh.